Have you ever taken ibuprofen before? Did you know that ibuprofen has two enantiomers, where one is better than the other? An enantiomer is like your hand. It can be left-handed or it can be right-handed, and the two hands are different as they can't be placed on top of each other. Similarly, a left-handed drug called an enantiomer behaves differently from a right-handed drug in the body. Now, ibuprofen is usually sold containing both enantiomers because the cost of making only one of them is too expensive. One way to improve ibuprofen and many other drugs is to find a way to make only one enantiomer cost effectively. Drugs are typically made by combining smaller compounds together into larger ones, and one of the most common building blocks are secondary alcohols. They are made by taking a ketone, which has a double bonded oxygen, and adding a hydrogen. This produces two compounds, two enantiomers, one in which the OH is going to the front, and another in which the OH is going to the back. And again, they behave differently as drugs. Now, in order to produce only one enantiomer, which is needed to prevent disasters similar to the one with thalidomide, in which thousands of children experience permanent side effects, drugs should be made with only one enantiomer, and this is achieved with a catalyst, more specifically an organometallic catalyst. However, they're expensive, bad for the environment, and are a limited resource. Plants, on the other hand, have enzymes called ketoreductases that can also catalyze the reduction from a ketone to a secondary alcohol enantiomer, and only one of them. However, the use of plants as biocatalysts has not been well studied, even though they are 50 times cheaper than organometallic catalysts. In this study, I improved the performance of beetroots to achieve a 70% conversion from ketone to alcohol and a 92% enantiomeric excess.